Imagine a software update so complex it requires 3 full months of human labor. Now imagine a machine finishing that exact same task before your lunch break is over. This isn't a hypothetical. Fujitsu just proved it's possible with a new architecture called Takane. It's not just a chatbot, it's an autonomous engineer that understands legacy systems better than we do. We are witnessing the birth of the Agentic era, where AI doesn't just suggest code, it manages the entire lifecycle from design to deployment without needing a human to hold its hand. Fujitsu's Takane isn't your average LLM. It was built specifically to tackle the messy, undocumented world of enterprise software. It's designed to think in systems, not just sentences. In a recent trial, they threw a massive challenge at it, modifying a legacy system that would normally take 3 person months. That's hundreds of hours of human focus. The result? Takane finished in 4 hours. Not only was it fast, but the code was clean, tested, and ready for production. It's an efficiency gain that feels like science fiction. But how did it do it? The secret lies in Fujitsu's unique multi-agent framework. Instead of one big brain, they've created a team of specialized AI experts. One agent analyzes the requirements, another writes the implementation, and a third tries to break it. They argue, they refine, and they converge on a solution. This collaborative approach is what allows Takane to handle the software lifecycle autonomously. It's a massive leap from simple autocomplete to full-scale automation. Most AI models struggle with hallucinations or losing track of the big picture. Takane solves this by grounding its logic in the actual technical architecture of the system it's working on. It doesn't just guess what comes next, it understands the dependencies, the database schemas, and the security protocols. It's like an engineer with a photographic memory of the entire codebase. This level of technical accuracy is what makes it viable for enterprise use. You can't afford close enough when you're managing banking systems or power grids. The implications are massive. If we can compress months of work into hours, the speed of innovation doesn't just double, it goes vertical. But it also raises a big question. What happens to the millions of people who currently do this work? To understand the economic impact, we have to look toward 2026, and the answer might surprise you. We're heading toward a world where the role of the software engineer changes forever. Let's dive into the architecture that's making it happen. To understand Takane, you have to understand Agentic AI. Most LLMs are passive. They wait for a prompt. Takane is active. It sets its own goals and executes them. It uses a generative AI mixture of experts approach. This means it can swap between different specialized models depending on the task at hand, whether it's writing Java or optimizing SQL. By specializing the models, Fujitsu reduced the computational cost while dramatically increasing the accuracy for technical tasks. It's efficiency at its finest. The design agent is the first step. It takes high-level business requirements and translates them into a technical specification that a machine can actually understand. This isn't just a summary, it's a deep mapping of every function, variable, and dependency needed to make the change work without breaking the rest of the system. Think of it as the architect who draws the plans before the construction crew even arrives on site. It prevents mistakes before they even happen. Next comes the implementation agent. This is the workhorse. It takes the design and starts writing the actual code, following the strict rules of the target environment. It doesn't just write new code, it refactors old code. It can look at a 20-year-old COBOL script and understand how to integrate it with a modern cloud API. This ability to bridge the gap between legacy and modern systems is Fujitsu's secret sauce. It's what makes Takane so valuable to big corporations. But writing code is only half the battle. The testing agent is where the real magic happens. It creates its own test cases to try and find bugs in the new implementation. If it finds a bug, it doesn't just report it, it sends it back to the implementation agent with a detailed explanation of what went wrong and how to fix it. This internal debate between agents continues until the system is 100% confident in the solution. It's a level of rigor that's hard for humans to maintain over long periods. Wait, does this mean the system is perfect? Not quite. Hallucinations are still a challenge, and complex edge cases can sometimes trip up the agents. Fujitsu admits that human oversight is still crucial for high-stakes decisions, but the amount of work humans need to do is shrinking fast. The real breakthrough isn't that the AI is smarter than us, it's that it's faster and more consistent, and that's about to change the global economy. By 2026, autonomous software platforms like Takane won't be a luxury, they'll be a necessity. The companies that don't use them simply won't be able to compete on speed. We're looking at a world where software is updated daily, not quarterly, where bugs are fixed before users even notice them. The software engineering title is about to get a massive upgrade, but this isn't the end of coding, it's the evolution of it. Let's look at what the numbers actually say about the future of work. The economic impact is staggering. Some analysts predict that the cost of maintaining legacy software could drop by as much as 80% within the next few years. That's billions of dollars being freed up, money that can be reinvested into new products, new research, and new human-centric innovations. This isn't just about saving money, it's about unlocking human potential. When you don't have to spend months on maintenance, you can spend months on creation. So, what does the software engineer of 2026 actually do? They become AI architects. Their job is to guide the agents, define the high-level strategy, and ensure ethical alignment. Instead of writing individual lines of code, they'll be writing the rules of the game. They'll be managing fleets of agents that do the heavy lifting. This shift requires a new set of skills: system design, prompt engineering, and deep domain expertise. The coder is becoming a director. Of course, there are risks. Security is a major concern. If an AI can write code that fast, it could also potentially find vulnerabilities just as quickly. That's why Fujitsu is building guardrail agents, specialized AI that does nothing but check for security flaws and ensure compliance with global standards. The battle for cybersecurity is moving to the AI layer. It's an arms race of algorithms, and Takane is right at the center of it. Fujitsu's Takane is more than just a technical achievement. It's a glimpse into a future where the barrier between idea and implementation is almost zero. The 4-hour miracle was just the beginning. As these agents get smarter and more integrated, the way we build the world is going to change in ways we can barely imagine. The question isn't whether AI will take over software engineering. The question is, what will you build when the machine does the work for you?